two particles which are initially at rest move towards each other under the action of their internal attraction. If their speeds are v and 2v at any instant, then the speed of center of mass of the system will be. Suppose both particles are on x-axis. This is x-axis. एक particle है A and second particle is B. A and B. A का मास m1 और B का मास है m2. Initially their velocity is 0. So initial linear momentum will be 0. After some time, due to their mutual attraction, A की velocity becomes v1 and B की velocity is v2. v1 vector is equal to v I cap and v2 vector is minus 2v I cap. Final momentum is m1 v1 plus m2 v2, and this will be equal to initial momentum, or m1 v I cap minus 2 m2 v I cap is 0. So m1 minus m2 2m2 is 0, or m1 is equal to 2m2. Velocity of center of mass is m1 v1 plus m2 v2 upon m1 plus m2. m1 had 2m2 and v1 is vi cap. m2 minus 2 vi cap, m1 plus m2, that is 0. So speed of center of mass is 0. B is correct option. Next, a circular disk of moment of inertia it is rotating in a horizontal plane about its symmetry axis with constant angular speed omega I. Another disk of moment of inertia IB is dropped coaxially onto the rotating disk. Initially the second disk has 0 angular speed. Eventually both the disks rotate with a constant angular speed omega f. The energy lost by the initially rotating disk due to friction is. एक सर्कुलर डिस्क ये एक्सिस ऑफ सिमेट्री पर रोटेट कर रही है इन हॉरिजॉन्टल प्लेन. इसका मोमेंट ऑफ इनर्शिया इज it एंड एंगुलर स्पीड इज ओमेगा I. Initially angular momentum is it omega I and energy EI is half it omega I square. Now second disk is put on it coaxially. और सेकेंड डिस्क का मोमेंट ऑफ इनर्शिया इज ओमेगा बी. अब ये combination rotates with omega f. तो combined या resultant moment of inertia will be IB plus IT, and final angular momentum will be IB plus IT into omega f. The system as per no torque is applied, hence angular momentum will be conserved. So LF will be equal to Li, or IB plus IT omega f will be equal to IT omega I, or omega f is IT upon IB plus IT omega I का square. Final energy EF is half IR omega f square, or half IR is IB plus IT and into IT by IB plus IT omega I इसका IT square. Half IT square omega I square by IB plus IT. Loss of energy due to friction, that is EI minus EF. EI is half IT omega I का square minus half IT square by IB plus IT omega I का square. Half IT omega I square 1 minus IT by IB plus IT. ये आ जाता है हाफ IT IB plus IT omega initial का square. This D is correct option. Next, from a circular disc of radius r and mass 9 m, a small disc of m and radius r by 3 is removed concentrically. The moment of inertia of remaining disc about an axis perpendicular to the plane of disc and passing through its center S. एक डिस्क एक axis passing through its center and perpendicular to the disc. Disc का mass is 9 and radius is r. So IO will be equal to mr square by 2. m है 9m r square by 2. Now सेंटर से m मास की डिस्क is removed. This is removed. Inertia of removed disc moment of inertia about axis O dash O double dash I O dash will be मास और इसकी रेडियस है r/3 r/3 का स्क्वायर बाई 2 mr स्क्वायर बाई 18. Moment of inertia of remaining disk that will be I0 minus I dash O 9 mr square by 2 minus mr square by 18 81 minus 1 mr square or 80 by 18 mr square 40 by 9 mr square 40 by 9 mr square. A is correct option. Next, a thin circular ring of mass m and radius r is rotated about its axis with constant angular velocity omega. Two objects each of mass m are attached gently to the opposite ends of the diameter of the ring. Ring now rotates with angular velocity given by. एक थिन रिंग, इसके एक्सिस AOB along रोटेट की होती है. इसका मास इज m and radius is r. इसका मोमेंट ऑफ इनर्शिया अबाउट AOB I AOB is equal to mr square. Angular velocity is omega. So Li initial angular momentum will be IOB into omega or mr square omega. अब दो पार्टिकल each of mass m are put on these points C and D. M. Final moment of inertia about OAB I dash AOB is mr square plus 2 mr square. This is moment of inertia of ring and this is moment of inertia of two particles. M plus 2m r square. Final angular speed is omega f. So LF will be final angular momentum will be I dash AOB into omega f, or m plus 2m r square omega f No external torque is applied on the system, hence angular momentum will be conserved, hence LF will be equal to Li, or m plus 2m r square omega f will be equal to mr square omega, or omega f will be m by m plus 2m omega. This D is correct option.